Hello, today's recording is about the call stack. So the call stack it is a data structure and it has a last in, first out approach. So we'll get more into depth with that, and it stores information about active subroutines of a computer program. And it's very fundamental to understanding how programming languages work and how programs are executed. So it is used to manage function invocation calls and return addresses. Keep that in mind, very important. The call stack, just like we said, LIFO method, and meaning that the last function that was pushed onto the stack is the first to be popped off. So we're going to see how that works in action in a minute. But when a function is called, it is added to the stack. So we say we have this stack, right? It's going to be a stack. And when the function completes, it is removed from the stack. But say we have one function, then we have another function, then we have another, and then we have another call to a function. And then once that function returns something, it gets popped off, and it keeps going until it's removed. But that's a pretty simplified example of it. There's a little bit uh, more we got to go over because what about the code um, that comes after a function call and vice versa? So when the function completes, it is removed from the stack. The stack keeps track of the current position in the program's execution. And if the stack becomes full, an error called a stack overflow occurs. So I would say that a stack overflow, what we already know from the famous website. I'm not being sponsored, but I'm just saying, just throwing it out there. But that's where they get it from. But basically, it's because like somewhere in the browser or even on our computers, um, we only have so much space and memory allocated for our stack. And when we're using too much of that, then we're gonna have a stack overflow. We're done. Our program's done. It's you know what I mean. It's not a good thing. So like we need to know. That's why it's very important to know how much space is allocated. But I mean that's a whole other. I don't want to get into the complexities of that. For now, we need to focus on this stack, the call stack, and how it's working. But to think about the Stack Overflow, I guess we could think about it. If we're trying to simulate that with this program, then we can have like first function and second function calling each other, where first function's calling second function's calling first function, and then of course we invoke one of them, and it's just gonna keep going and going and going until we have a Stack Overflow, similar to an infinite loop, but not quite. It simulates recursion in a way because, like recursive functions, it's a function that calls itself repetitively until a certain condition is met. But that's another concept as well. But let's get into it. So, if we run our debugger here, what we want to do is we want to put a breakpoint here where we have our function invocation. And you might think, because I tell people in the mentorship program that JavaScript code executes top to bottom, left to right, so you might assume that that's what's going to happen. It does, in a way, but not exactly that way. So if you want to pause the video and take a guess how all this code's gonna function before we step into it, then that'll be cool, just to challenge yourself. All right. Remember, there's no right, there's no wrong, and even when you're wrong, who cares? You can always there's that means that that's something you can focus on. That's a learning opportunity, basically. All right. So we got and here we go. We're gonna step into our function. You're gonna notice our call stack here, and then we're gonna have our variables here. But we want to watch these two areas because when we step into our function, we have the global function, which is like a main function that's gonna be added to the call stack. But we're adding it with the third function because our function call so it goes to the third function. It's gonna, it didn't start from line 7. It went straight to the function call. It's in the global scope, and I like to tell people to think about, we can make a video on scope, but I like to tell people to think about scope as like global is out in the yard, function is like, or local is like rooms in the house. Like you can only see only code that's in the same room can see each other, whereas the code out in the yard, everybody can see it, right? Or whatever's out in the yard, everybody can see it. So I know the analogy was but you get the idea. That's usually the analogy I like to use because it's really helpful. But we step into it again, and we're not going to line 18. We're going to go where? Yeah, we're going to go to line 11. And then we're going to go to line 12 and execute first function. We're going to go to line 7. And then we're going to go to line 8 and now we don't have a function call. And if you notice throughout our call stack, we're adding to the stack as we're calling each function, as we're doing the function call. We haven't returned anything yet, and now we return something. If you see, we have a return value now. I am the first function. Well, when we return that, we pop the first function off the stack, and now we pick up where we left off in the second function from that return address, and now we're going to execute line 13. I am the second function. Now we have that return value, and we're going to pop the second function off the stack, and we do it again, and we do it again, and now our stack is empty. And I'm just going to go ahead and stop the execution there. Um, but there is a difference between, like I said, there is a big difference um, between learning. This is a concept I feel like we should all know as programmers, of course, and it could be asked in the technical interview, so it's important to know it. But this is important. There's two contexts in which we should be learning this one. So we should be learning this in the context of now we're learning how a stack works, what it is, and how it works. The next step would be building one. How do we build our own stack? And that could be for another video. So in future videos, we could do scope and building a stack data structure, one that operates like a call stack. And but like I said, there's benefits to this. Is like a computer science, more in-depth computer science look. This is more of how you would learn about data structure and how it works and how it ties into programming in general, um, or your programming language. Um, more from a university perspective, they go more in depth. Boot camps, they gloss over it. I haven't seen any that go in depth with it, but I haven't been to many of them. Maybe nowadays they're going to get a little bit more involved with teaching more in-depth computer science concepts because they are very important. But if there's anything you feel I missed that I should go over, then drop it in the comments. If you're already in the dev community, then reach out on DM. Let me know if you have any questions, comments. Um, if you'd like to be a part of the dev community, then you have to be a part of the mentorship. So then you can go to my website, darkmodedevs.com, the mentorship section, and you can fill out the interest form. Let me know you're interested in mentorship, and we can start from there. But I hope this is helpful for any of you guys or anybody watching this, and you can also let me know where I can do better or better help you too as well. So hope you liked the video, and I hope you all have a wonderful day. Stay blessed.